Welcome to the brand new section of this course, titled Building Applications with .NET Core. In this section, we look at topics such as installation and commands of .NET Core, publishing a .NET Core application, using Visual Studio 2017. Now let's move on to the video, installation and commands of .NET Core. In this video, we will see topics such as how to install .NET Core, and creating and resolving .NET Core app, building and running .NET Core app, creating .NET Core app using Visual Studio 2017. Let's start with installation of .NET Core with Visual Studio 2017. To install .NET Core along with Visual Studio 2017, run the Visual Studio installer. If you have already installed Visual Studio 2017, you can modify the existing installation to install the .NET Core workload. When the installer starts, you will see this screen, where you can customize the workloads that you want to install. From the list, click on it and then click on .NET Core 1.0 or later development tools for web on the right pane as well, and then click on Modify. This will start the installation process. Once it completes, you may have to restart your computer for the changes to take effect. Once the installation is successful, open a console window and type in the .NET new command to populate your local .NET Core package cache, which will occur only once to improve the restore speed and enable offline access. When you use it for the first time, it will print the following output in the console window, which may take up to a minute to complete the installation. Next is a quick lap around the .NET Core commands. Here is the list of .NET Core commands. When you use .NET New, it initializes new project based on the project template and language that you select. The default is C#, and currently C# and F# are the only programming languages supported. This is the list of project templates, their short names to pass to the commands, and the language type for each template. For your reference, the .NET Restore command restores the dependencies and tools of a project. The .NET Clean command is used to clean the output of a project that was built earlier. The .NET Build command is used to build a .NET Core application. The .NET MS Build command provides access to the MS Build CLI to build a project and all its dependencies. When you want to publish a .NET Core application as a framework dependent or self-contained app, you should use the .NET Publish command. The .NET Run command is used to run the application from source. When you use .NET Test, it executes the tests using the test runner specified in the project.json file. When you want to create a NuGet package of your code, you should use the .NET Pack command in the CLI. When you specify the .NET SLN command, it allows you to add, remove, and list projects in a solution file. The .NET NuGet Delete command deletes or unlists a project from the NuGet server. The .NET NuGet Locals command is used to clear or list the local NuGet resources. Using the .NET NuGet Push command, you can push a NuGet package to the server and publish it in the NuGet store. After that, we will be creating a .NET Core console app. Let's first create a console application with all default parameters and options. Open a console window and navigate to the directory of your choice. Here we are in the demo directory. Then enter the command such as .NET New Console to create a console application project. This will successfully create the console application project, along with the code file, as you can see here, and that you can verify by going to the demo folder. In this folder, we have created a new folder named Demo in the .NET Core directory path, then navigated to that new directory, which is Demo in the console window, and given the command. As we have not specified any name explicitly, it will create a project in the context of the current directory, so you will see demo.cs project in that directory, with a C# file named program.cs. Let's create another project but this time we will specify a name and the language explicitly. Navigate back to the .NET Core directory in the console window and enter this command, .NET new console language hello.NET Core. This will create a new folder named hello.NET Core and a project of the same name. So let's go back to our directory and you can see here that the folder is created. Also, the project name is created with the same name, with a program.cs code file in C#. If you want to build an F# project, specify the option as language F#. Note that none of these commands create any solution file for the projects. To create a solution file from the CLI, use the .NET new solution command. Next, we will be creating a .NET Core class library. To create a .NET Core class library project, we need to use the same command, which is .NET new, but with the class library type project template, whose short name is class lib. Let's navigate to the folder .NET Core in the console window and enter this command. This will create a C# project named customlibrary.cs project and a C# class file, class1.cs, in a directory named custom library under the current directory, which is .NET Core. Now let's see creating a solution file and adding projects in it. Using the .NET Core CLI, you can also create a solution file and add or remove projects in it. To create a default solution file, enter .NET new solution command in the console window. This will create a solution file named .NET Core.solution in the current directory, as you can see here. In case you want to specify a name while creating the solution file, enter the command .NET new solution, demo solution. The solution file with the specified name will get generated in the same folder. To modify the solution file from the command line to add projects in it, provide the proper name of the solution and the project name. For example, when you want to add a single project in a solution file, use this command. Then provide the solution name. After that, add and then provide the project name. If you want to add multiple projects, use all the project names like this. Here I have added the project name once again to add it up. When you want to add all the projects available in the current directory, you can use asterisks. Similarly, you can remove any project from the solution file by using command such as remove and then project name. This command mentioned here is used to remove a single file. When there are multiple projects that you want to remove selectively, run this command. If you want to remove all the projects available in the current directory from the solution file, once again use the asterisks. Let's do this in practice. We will first create two .NET Core projects of types console app and class library. Then we will add them to a newly created solution file. Now navigate to the folder where you want to create these and work through these steps to build our first solution. Let's first create a console app project by entering this command. Create a class library project by entering the command as seen here. After this, create a solution file. We got error because we have already created the solution file, so let's go back and delete our solution file. Once again, create a solution file. Add the projects into the solution file. For that, add the command .NET solution. Write the name of the solution, which is demosolution.sln. Add and the project name, that is demo app. Inside this folder, project is located whose extension is .csproj. Then we will add custom library, and inside this folder, custom library.csproj, and enter it. you will get this message. After that, we will see resolving dependencies in the .NET Core application. Let's resolve the dependencies of the project that we have just created. Enter this command from the current directory. In our case, it is .NET Core. This will start restoring the .NET Core packages and dependencies. Unless these dependencies are resolved, you cannot proceed to build and run your application. Next is building a .NET Core project or solution. To build a .NET Core project from the command line, you can use the .NET build command. When you specify it in a directory with multiple projects, a build will be performed for all the projects. When there is a solution in the directory that has at least one project linked, performing this command will build all the projects linked in the solution file. Here's a link of the command extension. When you want to build a specific project or solution, provide its name or the path to it while executing the build command, such as .NET build demo app. This command will build the demo app project we have created. You can use the path as well, such as .NET build demo app, and provide the actual path of the project. Here's the result of the execution process to build the demo app application. Building a .NET Core project requires the dependencies to be resolved first. Hence, you should execute the .NET restore command at least once before building your code. So the output of the build will get generated in the bin folder of the project directories. By default, it builds against the debug configuration settings, but to build the projects in release mode, the configuration release option needs to be specified, such as .NET build configuration release. You can also build a specific project by providing the project name, such as .NET build, then project name, and lastly providing options of configuration release. You can also target the build for a different runtime by specifying runtime followed by runtime identifier. If you want to build the project or solution against the runtime of Red Hat Enterprise Linux 7, which is 64-bit, enter the commands .NET clean and then .NET resolve runtime RHEL, which is for Red Hat and Linux 7. And finally, providing bit that is 64. At this instance, there is no executable, so that's why this message pops up. We can also use .NET build runtime and Linux 7 and bits as 64 command. So here the first command will clean the current workspace. The second command will build the project or solution against the specified runtime. The third command will build against the runtime specified. Make sure to resolve the dependencies before retargeting to build to a different runtime. When you build a project or a solution, the output files are defined in the bin folder of the project directory. You can verify this going to bin folder and see that there is a release folder, which is created because we used configuration option such as release. For different runtime, we need to check this folder and verify this as well. All the temporary files related to build get generated in the object folder of the project directory, just like any other projects targeting .NET framework. Post that, we will learn running a .NET Core application. To run a .NET Core application, you can use the .NET run command from the console window. As it relies on the .NET build command, when you specify a project to run, it automatically builds the project and then launches the application. To run an app in the project context, enter the .run project option and then project path command. If you already have a portable application DLL, you can run it directly by executing the DLL by the .NET driver without specifying any command. For example, this command runs the already available DLL and give the output as Hello World, which is the default program. You can also run with the project name, such as .NET Run Project, Demo App, and inside this folder demoapp.csproj. This will give the same output as above. Next is publishing a .NET Core application. When you build, debug, and test your application successfully, you need to publish or deploy your app. The .NET Core provides the .NET Publish command to publish your app for deployment. To publish a .NET Core app in the release mode, enter .NET Publish command and add project name, with an option Release Mode. There are two kinds of deployment available for .NET Core applications, which are Framework Dependent Deployment (FDD) and Self-Contained Deployment (SCD). The first one depends on a system-wide version of the .NET Core to be present before running the application, whereas the second type of deployment does not depend on any .NET Core version already installed on the system, as it includes the entire .NET Core libraries and runtime, along with the resultant application files. Let's work through these steps to create, build, run, and publish an app using the FDD deployment model. Create a directory for your solution. For example, in our case, it is .NET Core, and navigate to it in a command window. Enter the command as seen to create a new C# and providing console name. This will create a console application. After this, create a solution file named FDD demo and add the project into the solution file. Now resolve the dependencies by entering .NET restore command. Post restoring, build the solution by running this command, which will generate the PE version of the application in the bin debug folder, which you can verify by going to debug folder. So if the build succeeds, the output DLL will get generated in .NET Core FDD demo bin debug netcore app 2.0, and inside this you will find the fdd demo.dll file. Now enter this command as shown here to run it. Once you are ready to publish your app, enter this command to create the release version of the project to the .NET Core. .NET Publish FDD Demo bin debug netcore app 2.0 fdd demo.dll in Publish folder. And you can verify it by going to Release folder. The Publish folder gets created with the DLL. Here in the FDD model, you will have only your app and its dependency files, if any, along with the PDB file and JSON configuration files in the Publish directory. No other files will get deployed there, thus keeping your deployment package very small. Following that, we will look at self-contained deployments. Let's work through these steps to create, build, run, and publish an app using the SCD model. Once again, you need to create a directory for your solution. In our case, it is .NET Core, and navigate to it in a command window. After that, enter the command to create a new C# console application, such as .NET New Console Language, C#, and then the project name that is SCD Demo. Create a solution file named SCD Demo and add the project into the solution file. For that, use this command as shown. Now open the project file scddemo.csproj in a notepad. Inside this file, create a runtime identifiers tag under the Property Group section of your .csproj and define the platforms that your app targets. Here you can set multiple identifiers separated by semicolons. Now resolve the dependencies by entering the command .NET restore. Next, build the solution by running this command. Enter the runtime identifier that you want your app to target, which will generate the output of the application in the bin debug net core app 2.0 folder. If the build succeeds, the output DLL will get generated along with the exe as .NET Core scd demo bin debug net core app 2.0 inside the runtime, and there you will find scddemo.dll and scddemo.exe file. Here we need to provide runtime folder as well, which is inside net core app 2.0 folder, and that is win10x64. You can also run the exe file directly by specifying the project path. Once you are ready to publish your app, enter the publish command to create the release version of the project, which will get stored in the publish folder, which is .NET Publish C, release Windows 10 64 bits. If you open the published folder, you will see project DLL files. You can create as many deployment packages as you want, based on your targeted RIDs. Separate folders will get generated for each RID package. Following that, we will be creating an ASP.NET Core application. To create an empty ASP.NET Core application, enter the command in the console window as shown. To create an MVC-based ASP.NET web app, you just need to replace web with MVC. To create an ASP.NET MVC web application with no authentication, you need to provide a /AU for authentication and provide the value as none. Or to create an ASP.NET Web API application, just replace this with Web API in the command line. By default, ASP.NET Core Web Applications uses SQLite for database support. You can change it to use LocalDB instead of SQLite. To change it, append either of the ULD, true, and then authentication as none, or use LocalDB options with the value true, as shown. Here's what happens after you enter the command and the files and folders that it generates. Instead of this syntax, we will enter the actual project name, which is MVC demo, and here we will use ULD option. This will generate the files and folders. You can verify the project by navigating to the project folder. In our case, we have created our project in C drive, Users, Test. So let's head back to Windows. Inside our C, User, Test, there is the project folder, and here is the file, which is MVC application. After that, we will be creating a unit testing project. Unit testing projects can also be created using .NET Core. In the command line, you can specify the template code, which is .NET new MS test, and then the project name to create a simple unit test project. If you want to create the XUnit respectively, you need to replace the MS test with the XUnit. This will create the XUnit test project. You can also run a unit test project from the command line. You need to execute the .NET test command to do so. The unit testing frameworks are bundled as a NuGet package and can be restored as ordinary dependencies. You can execute either .NET test command or else by providing the project path too. So in this way, you can test your project. Next is creating .NET Core applications using Visual Studio. We have seen the .NET Core commands to create, build, run, and publish .NET Core applications. We have also covered how to create and run ASP.NET Core applications and unit testing projects. Now, let's look at how to do it easily using Visual Studio 2017. To create a .NET Core application using Visual Studio, open the Visual Studio 2017 instance and click on File, New, Project to open the new project window. Alternatively, you can press the keyboard shortcut Ctrl, Shift and N. In the New Project dialog, navigate to Installed Templates, Visual C#, and .NET Core. Here you will see 5 types of template, such as Console App, Class Library, Unit Test Project, XUnit Test Project, ASP.NET Core Web Application. You can select the template you want to create. To demonstrate, let's create a console application first. From the available list of project templates, select Console App. Provide a proper name for the project and solution file. We will name it as Demo Console App. Select the location and click on OK to create the project. Like other project templates and unlike the CLI tools for .NET Core, this wizard will create the solution and add the project into it automatically. A class file named program.cs will be available, which is the entry point to the application. So let's build the application and run it. You will see a Hello World string printed on the screen. If you navigate to the bin, debug, netcore app 2.0 folder path of the project directory, you will see demo console app.dll, which is our application host. So here we have come to the end of this video. In this video, we first installed .NET Core and later saw some of its core commands.